continue here. This video is about percentages, and we will talk about common situations using percentages. Okay, let's continue. This is video number 18, part 2 of 6. I divided the video in 6 parts, and this is the second part. Let us continue here. Let's continue. Let's continue with the next section here. Okay, in this section we'll discuss some situations of using percentages. Okay, so next section is simple interest. One after the compound interest, some investment returns, and some discounts. Okay, let's continue. Let's look at some situations using percentages. We will discuss a few common situations. It's very hard to enumerate every situation because we use percentages in almost every field. Let us continue here. Example, in a game of basketball, Tom shot 3 free throws when he got an opportunity to shoot 5. Question, how many free throws did Tom miss? Know anyone? What's the percentage of missed throws? What's the percentages of missed throws? Let's continue here. Number of throws Tom missed is 2. He got opportunity to shoot 5 and he shot 3. 5 minus 3 is a 2. Okay. Missed free throw percentages is, first of all, he missed 2 out of 5. That's the ratio of missed shots to all the free shots he got. Then we do a multiply and divide by 100. So that gave me a 40 in the numerator and 100 in the denominator. That's 40%. Okay. So also 2 divided by 5 is 0.4, and when we move the decimal place to 2 places to the right, we get a 40, and that means 2 divided by 5 is 40%. Okay? 2 divided by 5 is 40%. So he missed 2 shots out of 5, so he missed 40% of the shots. Let us continue here. Let's continue with situations here. Example, Linda fixes salad consisting of half greens, which is celery, broccoli, and spinach, 1/5 orange, carrots, and orange bell pepper, 1/10 red, which is red beans and beets, okay, and 2/10 of whites, which is all mushrooms. Okay, let's continue here. So what are the ratios of the colors now? Okay, we get half greens, 1/5 orange, 1/10 reds, and 2/10 white. So ratio is green to orange to red to white, which is orange is half, that's a half, greens is half, that's half, orange is 1/5, that's 1/5 here, red is 1/10, that's 1/10 here, and white is 2/10, that's a 2/10 here. Okay. Now we're going to remove the numerators by multiplying each of these ratios portions by 10. Let's continue. So multiply half by 10, I got 5. Multiply 1/5 by 10 is 2. 1/10 by 10 is 1, and 2/10 by 10 is a 2. So green, orange, red, and white are in the ratio of 5 to 2 to 1 to 2. Let's continue here. So what percentage is green? Okay, it's 5 out of 5 plus 2 plus 1 plus 2. 5 out of 10. Okay. Answer ratio is 5 divided by 5 plus 2 plus 1 plus 2, which is 5 divided by 10, and which is 0.5. That's the ratio. And we're looking for percentages. Answer percentage is 0.5 times 100, which is 50%, and what we did is move decimal place 2 places to the right. So when you move 1 place to the right, become 5, when you move 2 places to the right, it becomes 50. So 50%. Let us continue here. In a school of 800 students, 16 students called in sick on Monday. Okay, so total number of students 800 and 16 were sick on Monday, did not skip the class. So what percentage of students attended the school on Monday? So some of the school students skipped the classes and rest of them attended the schools. Okay, let's continue. Percent of students, number of present students as were present were 800 were total, 16 were skipping classes, and 800 minus 16 is 784. So out of 800, 784 students were in the class that day. Percentage is 784 divided by 800. That's the ratio. We multiply that by 100 and call it percent. Okay, let's continue. That's 7.84 divided by 8. We divide both the numerator and the denominator by 100 here. So that's 7.84 divided by 8 times 100. That's a percentage. And that 7.84 divided by 8 is 0.98 times 100. So move the decimal place 2 places to the right. When we move 1 place to the right, it becomes 9.8, and when we move second one more times, it becomes 98, okay, which is equal to 98%. So if we move the decimal, first we computed the ratio, then we move decimal place to the right 2 places. Let's continue here. And what's the percentage of students that were absent? Present were 98%. The absence must be 2%. Let's see what we got. And 16 students for our 800 were missing, skipping classes. So there was 16 divided by 800, and that is 1 divided by 50. So if you divide by 8 here, it becomes 2 divided by 100. 8 divide the numerator and denominator by 8. That gets me 2 divided by 100, and 2 divided by 100 is 1 divided by 50, which is 0.02. That's the ratio. And percentage is 2%. What we do is move the decimal place from here, from 2 places to the right. When you move to 1 place, it becomes 0.2. When you move 2 places, it becomes 2.0. So percentage is number of students they attended school that day were 98, and number of students they percent, and number of students they skipped the classes that day were 2%. Okay, let us continue here. We looking at some more situations here. An arsenic in a water sample is 1 part in million. Okay, so when we looking for some trace amounts, we usually specify that as a part in a million, a part in a billion, in that kind of manner. Okay, let's continue. So arsenic water divided by water sample is 1 divided by 1 million, and which is 0.000001. Okay, and that is equal to, we multiply by, move decimal place 2 places to the right, right here, that becomes 0.30001%. Okay, so this is the ratio here, 1 divided by 1 million, which is 0.00001. And when move in percentage terms, we move the decimal place to the right 2 places and become 0.0001%. So arsenic in a water sample is a concentration of 0.0001%. Okay? And this 1 part in million that's used commonly looks lot more interesting than 0.0001%. Okay, let's continue. Example: in a school there are 30 boys and 50 girls. Okay, what's the ratio of boys to the girls? There are fewer boys. Ratio of boys to girls is 30 divided by 50, which is 0.6, and which is 60%. 30 divided by 50 is 0.6, and we move decimal place to the right 2 places, becomes 60%. Okay, let's continue here. What's the ratio of girls to all students? Okay, so there are 50 girls in a class of 80, Okay? 50 divided by 50 plus 30 is 5 divided by 8, which is 0.625, and when moved decimal place to the right two places becomes 62.5%. Okay? Now, observations. To convert a ratio to a percentage, we multiply that by 100. In example, in a school with half boys and half girls, ratio of boys to girls is half divided by half, which is 1, and 1 is 100%. We move decimal places to the right by 2. Okay? To multiply by 100, we move decimal places to 2 places to the right. Okay? To convert percentage to a fraction, which is a ratio, we divide by 100. An example, in a bag there are 40% black beads and the rest are red beads. What's the ratio of the red beads to all the beads? Black beads are 40% and red beads are 60%, and we're going to convert 60% to a ratio which is 0.6. What we did is move the decimal place to the left by 2. From 60 is 60.0, so we move decimal place to one place to the left becomes 6. One more place becomes 0.6, and we call it 0.6. Okay? Let us continue here. Exercises, and all the exercises are from James T. Glover's book. 2. Compute 4% of $45, 110% of 650 centimeters, 15% of 80 centimeters, 75% of 24 inches, and so on. Okay. Let's look at references here. Okay. First reference is Vedic Math Teacher's Manual, Volume 1. This is Elementary Teacher's Volume, and it's by Ken Williams, and you can find it at vedicmaths.org. PDF form is available for free, and print form you can purchase. Let's continue here. Second reference listed is the common reference, that's the primary reference, Vedic Mathematics by Bharti Krishna Tirthaji, and that is the primary reference on the Vedic math. Tirthaji is a founder of the Vedic math. Let us continue. Now here is Discovery Vedic Math by Ken Williams. It's a most complete, authoritative, and consistent notations, and this book is organized by sutras. Let's continue here. Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover used these books in his school. They're very easy to read, very complete, not as complete as Williams' book is, and contains significant geometry which I have not covered at all. Let's continue here. And Figuring by Skuntala Devi. I used some of the exercises from this Glover's book, and I used some of the examples from this book Figuring. Let us continue here.